let's get this PowerPoint. Okay. So, as I said at the beginning when you guys were joining, go ahead and create a TinkerCAD account, and you can create one for free using your Georgia Tech email. I think you can also just create one for free with any email, but a Georgia Tech email gets you free like multiple Autodesk products. So, Georgia Tech is very nice. Okay, so today we are going to be doing like an extension off of the Arduino card that we made a couple workshops ago. So don't worry if you missed that workshop, you can watch the video or just like look at this TinkerCAD and like to get like a deeper understanding of what everything does. But I will quickly kind of go through like a review of the like what the car was. Okay, so
Wait, if you're screen sharing, I can't see it, by the way.
Mhm.
It might just be me, but
uh,
wait.
I think it might be you because I can see it.
Oh, wait, I
Um,
slid the slider thing. Okay, never mind, sorry.
cool. So this is our car running with a potato battery. So JJ can send you guys the link to this TinkerCAD file, and then you can use this copy and tinker button. It'll be it'll be this little blue button on your screen, and then you can use that to like build off for the rest of the workshop. Okay, so this car, so the biggest like cool component is this L293D that is a quad half H bridge. So basically that just means it's two H bridges in one. And what an H bridge allows you to do is like you can control two different motors with just two power signals, with just like two pulse width modulation signals. So like I can send a like right motor power, positive or negative, and then I can send a left motor power, positive or negative. Or so you can't like send it negative. You just send a power value to like the reverse power pin. You are new to Arduino. Yes, please ask questions in the chat if you're confused about literally anything. Why do we need the H bridge guy? So the H bridge allows you to it allows you to like control the current. So you can have like a constant voltage going through your motor, but the H bridge is built up of transistors in like a unique orientation that it's going to take me a little while to explain right now. But basically the transistors allow you to control the amount of current going to each motor, and you can also control the direction of that current going to each motor, which allows you to control the speed of two motors and the direction of two motors with just like four signal lines rather than like having to do a bunch of weird stuff directly connected to the motors. And then another thing this circuit has is an ultrasonic sensor, which has a a like a it has these two like sound like essentially like kind of like speakers. They look like eyes. So one of them it sends out a small sound wave, and then the second one kind of listens for that sound wave. So you send a little. So there's a trigger and an echo, and that's what you see with the little T and the R. They're a little bit covered up by the circles, but it's the top one is triggered and the bottom one is receive. So it sends out a sound wave and then it'll bounce off of something and then come back into the receive. And then you can measure that time delay and that gives you a distance reading. And then the way this guy actually works is if we start the simulation. So before I continue, do any of you like have this circuit pulled up and you guys can kind of like see what it's doing? Yeah, nice. Okay. So you can see that the motors are spinning pretty fast, right? But now if I kind of like tell the ultrasonic sensor that there's something very close, you'll see if you can see these numbers, I think you can. It is now a negative number. So the car is like, oh no, there's something really close, so it needs to go in reverse. And then when we move this little dot really far again, the motor's like, oh, Gucci, and then it goes forward. So this is a very dumb car. It just like goes forward and backwards based on if there's a wall in front of it. But basically, you guys can watch back the video for like a better understanding of how you could use an ultrasonic sensor and then also control motors in any like circuit you wanted to make. What is the potato? Yes, the potato is the battery. So the potato is configured to be 12 volts and have like zero internal resistance because you can use any like voltage source and just configure what it outputs. So it is sending the power into like the ground and power rails of this breadboard. So I think it was Neil who was asking about the breadboard earlier. Um, so like this is the power and ground rail coming from your battery. And then yeah, we did use different motors last time. So sorry about that. Those motors are like they're like they like spin a lot faster, but then these yellow ones are more meant for this application. They have like actual axle thingies that you could attach a wheel to. I can actually grab a physical one really quickly. Look, this is what this motor looks like physically, and it has like a little axle that connects to an actual wheel that can like spin, and then it has these two like wires coming out of it. Can a potato carry a current in real life? Yeah, I believe it can. It's just going to be a very low voltage, but we can, in TinkerCAD, we get to tell it it's a magic potato. Yeah. So one like downside of TinkerCAD is you can't actually simulate using an external power source on the Arduino, but we did kind of explain how you would set that up. So you have the power and ground from the potato coming into these top power rails. And then what you do is you connect this ground rail to the Arduino. So we are just kind of piggybacking off of this other ground rail and connecting that to the Arduino's ground. And then you can connect the power to the VIN pin of the Arduino. And that basically allows you to power the Arduino using the voltage in and the ground. And the reason you might want that is you might not own a battery that can plug into this little, like this type of port. So, like being able to just power the Arduino from pins is often very convenient. So you don't have to buy a like a power adapter. And then yeah, so now let's get back into our presentation. So that was a quick review of the car. So feel free to like play around with it. You can look into the code. We'll go through the code as well once we move on to like using the controller. So now I will quickly explain what serial communication is and a couple different ways to do it. So there's three main types. There's TTL serial, in which two wires are used for extremely basic communication between any two entities. And the main reason that you'll often see I2C or SPI rather than TTL is because TTL is limited to only two entities, whereas the other two can handle a lot more. So I2C is a little bit more advanced. It allows you to communicate with up to 255 entities using like addresses. And then the SPI is even more complicated than I2C, and it has a higher bandwidth. And if you don't really know what bandwidth is, that's like essentially data per time. So today we're going to be using I2C. It's written as I2C, so you can either pronounce it as I2C or I2C, and most people will understand. So this is just a very short like description of like what the data is sent on the what data is sent on the wire for I2C. So you have like a message, and then you have a start condition, which basically just tells the receiver, like either the leader or the follower, that a message is starting. And then you have this address, which is 7 or 10 bits, which is what you use to actually choose like which device needs to accept this message. And then this is a read-write bit. So this is used for, it's write when the leader is sending a message to the followers, and it's read when the leader is like asking for input from one of the followers. And when I say leader follower, that's referring to like master slave, how you might understand it, but we're going to use leader follower. And then each little bit of data, or each little section of data, is associated with an acknowledgement bit. And then after our whole message, we have a stop condition. So thankfully, there's libraries that do all of this for us, and you can use like the I2C protocol without knowing a single thing about how this message works. But just I thought having an understanding might help you guys appreciate it a little bit more as we work with it. Okay. So now you can go ahead and create an empty TinkerCAD sketch, and I will quickly walk you through creating a like I2C connection between two Arduinos. If you don't want to create it from hand, you can just click that link, and I have like a pre-built one. But I will quickly walk through, and you guys can follow along, like doing the wiring and the very basic coding of the I2C. Okay, so let's first make a blank sketch. Create new design. And again, please ask questions, just like ask whatever you want in the chat. Oh, I clicked design, not circuit. So interestingly, TinkerCAD, you can also use it to create 3D models, but you'd much rather use like something more meant for that type of development. Okay, so the first thing we will do is let's pull in two Arduinos. We can, in this components thing, we can select Arduino, and then we can just grab two little dudes. So TinkerCAD is quite slow. It might be a little bit hard for you to use. You'll just have to get used to the fact that it's a little laggy. So that is our first Arduino, and then we will bring in another Arduino. And yeah, as you can see on the right, TinkerCAD provides you with quite a few like small templates that you might find useful when you're like first starting out. Okay. So the first step in wiring them is, the first step is wiring them. So what we need to do is the way I2C works is there's only two wires, and the two wires work is you have a clock line and a data line. So for this one, the A4 is your serial data line, so that's where we're actually sending data, and A5 is your serial clock line. And so then you want to connect the A4 of each device to the A4 of each other device. So for us, since we only have two devices, we can just connect them like that. And we'll connect A5. And please let me know if you need me to slow down or if you want me to draw these wires like following like vertical and horizontal a little bit, make it easier for you to see them. And so what I just did to change the color is you can click this little drop down and change the color. And then the other thing we have to do is we actually have to connect the ground of each of our Arduinos. And the reason for that is to make sure that the voltage values are relative to the same ground. So like you may not know this, like the way like voltage works is it's all about potential differences rather than just like an absolute like voltage value. So connecting the ground makes you like it makes the relative position of like 5 volts or like 2 volts the actual like same value. So then the like the clock and data lines are actually sending good values to each other. How did you know it's A4 and A5? Is that arbitrary? So it's just part of the Arduino like specification. So you can Google Arduino pinout and it'll have like a label next to A4 and A5 that are SCL and SDA. And there's actually two more SDA and SCL pins. So yeah, you can see right here it's showing up. So you have SDA on the right and SCL on the left. But unfortunately, they aren't labeled, and on a lot of Arduino products, they aren't labeled. I think it's a little bit silly. They give you the two pins, but they don't label them. But like you can still use these two SCL SDA pins for the exact same functionality as A4 and A5. But like yeah, you can't use A0 and A2 if that's what you were asking for like I squared C. So let's go ahead and just make this ground wire be black. Okay, so now we will write the code for our leader Arduino. So we can pull up the code and it'll start as block code. I highly suggest against using block code. You are a CS major. I hope you use text code. Okay, so the first thing we need to do is we need to import the library that allows us to use I squared C. And so the way you do that so Arduinos use C++, and the way you can import things is using a pound include or hashtag include statement. And when you want to include libraries rather than like local files, you put the file name with chevrons or less than greater than to like describe it, to like denote the file name. And the import is wire.h, so you just do hashtag include wire.h. I don't know how to code without blocks. Okay. Well, today we're gonna learn, but I highly suggest you contact other resources to learn the basics of coding. Okay. So the next thing we'll do is we will set up the serial monitor for our leader Arduino. So what the serial monitor is, it's this guy, serial monitor. And this basically is like your system.out.print from Java or just like print from Python. It's basically just a way for you to get output from the Arduino so you can debug things. So the syntax is serial with a capital S dot begin and then your baud rate. So the standard is to just use 9600, but you can use something faster if you would like to. So that is going to set up our debugging. And the next thing we need to do is set up our I squared C communication. See, there's a question. I only know C block block. Okay. Well, today you're going to learn C++ instead of C block block, Alex. Okay. So serial.begin, and then to initialize our I squared C, we will do wire.begin. And you'll notice we'll do something very similar on the follower Arduino, and I'll explain what the difference is when we get to that guy. Okay, and then in our loop, we will just send a value to our follower, and then we'll just have the follower just like when it receives the value, it'll just print it out. So in our loop, we want to do wire.begin transmission. And then you want to pass in a device ID. So for this, we can just use like ID 5. It does not matter what the ID is. And then the way you actually send data is wire.write. And then it takes in a byte of information, but C++ doesn't have a byte data type. So what we'll do is we'll just create an unsigned char or unsigned char, however you feel like saying it. And that is just going to be a value from 0 to 255, which is exactly 8 bits, which is a byte. So we'll just create some data variable. We'll initialize it to 0. But that's not 0. And then we will write the data to the line, and then we will wire.end transmission. So as you can see, we didn't have to worry about like the start condition and the device address and the read write and like the acknowledgement bits and stuff. So that's like a huge reason that the wire is so convenient to use. And I just realized I made a typo here, so wire.write, I still can't type. Yeah. Okay. And then here we will just serial.print that we sent a message. So we print sent and a couple space bars, and then we will print the data. So these two lines are sending the data over this green wire to the follower Arduino, and these two lines are going to print things to the monitor. So let's actually see what happens when we click start simulation. Did not start. Okay. So here you can see that it's just repeatedly printing sent 0, but then the other Arduino isn't actually doing anything because we haven't written any code for it. So what we can do is if we stop the simulation, we also don't want to only send zeros because that makes it hard for us to tell if anything is happening. What we can do is just data plus equals 1000. So obviously 1000 is bigger than a byte, but I'm just doing a random number so that the value will just change to some random other number, and we can see how the values change. And then here, I will add a delay of 1000 milliseconds, and that will allow us to just kind of like actually be able to follow what is happening, so we can see a new number sent every 1 second. And you can use this to clear the old one. And if you saw, they were all printing in one line, and that's because I forgot to use print ln right here. So does everyone have something similar to this working so far, for those of you who are trying to follow along? Feel free to just like unmute if you have a question or just say it in chat. Okay, so that was the code for the leader, and now we need to make the code for our follower. So again, let's switch into text coding. And again, we can use the same library. It's not like a different library for the follower. Wire.h. And then in our setup, this is where the difference comes in. So we will serial.begin 9600 as usual, and then wire.begin, and then here we actually pass in an ID, and this basically tells the library that this device should be configured as a follower rather than a leader. And then, yeah. And then the next thing we do is we have to configure what this follower should do when it receives data on the line. So you'll do wire.on receive event, and then semicolon. And then what we can actually do is we can create a receive event method that takes in a length, which is the message length. And then right here we can just do we can do unsigned car data equals, and then what you can do is just the same way we write data, we can just do wire.read, and now we have a data value from the wire, and then you can do serial.print Eve, and then serial.print ln the data. And then here we can just remove this loop code because we don't want to. This is just like a simple example where the Arduino just is going to print stuff when it receives. Yeah, so Arduino uses like just C++ as its like the language. Start simulation. Oh no, we have an error. Receive event was not declared in the scope. Oh, I misspelled it somewhere. Receive. It would help if I could spell. Okay, so now if we open our serial monitor, you can see it received 0, and then received 232, and then let's see one more value, and then we'll go to the serial monitor of the first one and see what values it's sending. So it has 0, 232, 208. So if we look at our leader, we can see that it sent those exact same values. So now we are able to just like send values over to the other Arduino over just 2 wires and a ground wire. So yeah, very cool. So I know we are already at 7:30, so we underestimated how much time this would actually take. So if you have to go, feel free to do so, but we will actually be explaining how you can apply this I2C protocol to control this car. So if you want to stay, feel free to do so, and we will kind of go in depth of how you can use that control system to control this car. Steve, can you go back to the receive event method? Yeah, I can. Okay. So on the follower side, we have wire.onReceive, and then we pass in the pointer to the method, which is just the method name. And then here you just declare your method, accepting one parameter of length.
Wait, so
Okay,
which
seems
one
like
is
you
the
also had a spelling
follower?
error. Say that again?
Which one is the follower? The one on the right?
The right side is the follower. So you can see right here it says Arduino R3. So right here you can see that it says name one. So if I change this to like Bob, it should hopefully it updates. I don't know if TinkerCAD is smart enough for this. No, it does not. So this is just pointing to your first one, which was this one, and then this one is your second one.
Got it. I think I did it the wrong way by mistake the first time. Can I just
It
like
doesn't really matter
change the
like which one
numbers?
is which, but yeah. Also,
Okay.
yeah, thanks for coming, Aviva. Feel free to like head out, but thank you for coming. And yeah, we'll have the recording up as soon as possible, and you can watch that. Okay. So for those of you who are staying, I will go ahead and copy and tinker the car, and then we will implement our controller. Oh, thank you for coming, Eric. Yeah. Bye. Have a good weekend. You too, Mahir. See you next week. So we have this little car, and then we will pull in our one Arduino, and we just want like a blank Arduino, so I'll just grab this guy, and then I'll delete the little input piece. So what I'm doing now is I'm just connecting the ground A4 and A5 the same way we did for the previous example. And I will make these different colors to make it easier to see. So now we can do the same thing that we did on this Arduino, but what we want to do is we want to have some sort of control. So what we can do is add two like potentiometers to this first Arduino, and then it can send those potentiometer values as power values to the car. So let's bring in a breadboard for ourselves. Let's see if I can just grab a breadboard. Yeah. Okay. So I have this breadboard, and then we will connect the ground to the ground of the breadboard. And let's go ahead and make it a black wire. And then we will connect the 5 volts to the breadboard as well. I missed the board. Okay, and this guy can be red. Now let's go ahead and wire up some potentiometers like we did in one of our past workshops. Okay. So this potentiometer can be our left power, and this other one can be our right power. Okay. So the first thing we'll do is we'll wire up the power and ground pins for the 2 potentiometers. You got your, that's not right. Ground. This one is also coming to ground. Then from this side we will come to power. And the last thing you want to do is you want to connect the data line of the potentiometer to one of your analog inputs. And now we can get a value from 0 to 1024 from the potentiometer. Sorry for the wires being poorly colored. Here, I can make these 2. Let's make this ground one black, this ground one mouse now. We'll make this one red, this one red, and now hopefully you can easily see this stuff. Okay. Now let's go ahead and configure this Arduino to just send power values to this Arduino. What we'll do is we'll go to our code, and then we will switch it to text. And so it'll have like default code from the initial the template Arduino that we pulled in, but you can just delete all that. And let's include our wire.h, and then let's set the serial.begin 9600 wire.begin, and this is our leader, so it doesn't need to do anything. And then this pin mode is what we use to configure our 2 potentiometer inputs. So you have A0 is an input because the analog pins are A0 through A5, and then we have pin mode of A1 is also input. And then as you can see right here, we can use analog read to read from the ultrasonic, from the potentiometer. Sorry, I am messing up my English. Okay. So what we'll do is we'll read the left and right values from the potentiometers. So let's grab an unsigned left pot equals analog read from A0, and then we'll do the same thing for our right side. And then if you remember the I2C protocol, you can only send bytes of data. You can't actually send an integer, which is a lot more than a byte. So then what we will do is we will send, I did not spell that right. an unsigned car which is the left value divided by 4. So basically we're just scaling down the 0 to 1024 into 0 to 255. Or it would actually be 1023, not 1024, sorry. And then we'll also do the same for the right side. Right. And now the way we send data is we'll do begin transmission, and we'll send it to ID 5. And then we'll just set up the custom that we just always send the left value and then the right value, and then when we read them, we will just remember that we need to read them left and then right. Okay, and then we do our end transmission, and we add in a little delay so that it's not constantly sending like adjustments when barely anything is changing. So just a small 10 millisecond delay. So the loop will run 100 times per second. So we still have pretty fine control of our car. Okay. And now we can come over to the car and click on this guy. And then here we want to include the library as well. So your code may look a little bit different if you are using one of your own like car circuits from a previous workshop, but like I will just explain it as if we were using the base code from the template. Okay, so we'll include our wire library. We will do the same setup things in our setup method. So right in here, we'll do wire.begin, and then we will do our device ID was 5, so then we'll pass in 5 right here, and then we'll do this onReceive in the same way. Wire.onReceive, and then we can do receive event. Hopefully I didn't spell it wrong this time. Okay, and now rather than doing this like measure the potentiometer and then set the speed in the loop, we actually want to just set the speed when we receive a command from the controller. So in our receive event code, we will set the drive and then we'll clear out the loop. So void receive event, and we have our default parameter length. And then once in our receive event, we will pull out the left and right values. So we do unsigned car lval equals wire.read, and unsigned car rval equals wire.read. And now we need to actually convert this value, because if we look at the documentation for our set drive method, it's actually taking an input of negative 255 to positive 255, and then it's handling that logic for the motor controller within the method. So we need to take a 0 to 255, which is actually representing like negative to positive speed, so we need to scale it into the correct range. So the way we can do that So we'll do int left pow equals, and then we need to take a 0 to 255 and map it into negative 255 to positive 255. So what we'll do is we'll first scale it up by 2, and then we'll subtract 255. So now 0 would get mapped to 0 times 2 minus 255, and then a full 255 would get doubled, and then subtract 255. So now we've successfully mapped the values, and then we can do the same for the right power. Then we'll subtract 255, And now we can call our set drive function with left pow and right pow. Okay. And then we can go ahead and add in a serial.print for our own debugging purposes. So we'll do left, and then we'll do the same thing for the right. There. And so now this guy is going to just display what it received. And what we can do to make each line of like debug statement print in like the same format, or like within one line, we can just take off the ln from this one and then just add in some space on the second one. And then here we want to just clear out our loop code. Now, let's see if we coded our car correctly. So right now, the two motors are going at a high negative speed. See if that's visible on the blue jeans. Yeah, so right now it is at negative 344. So let's look at where our potentiometers are. So I know it's a little bit annoying me having to scroll around just so you can see everything. See if I can, fortunately I can't really help with that. Okay, so if we now like move the left one to like past the midpoint, so it should be a slightly positive number, but it's still a small number, and then we'll make the right one all the way at the max value. Now let's look at our motor. So the left one, which is the top in this case, is at 80 RPM, and then the right is now positive 344, which makes sense, and the previous one was negative 344. Yeah, and so now if we look at the serial monitor of our follower, we can actually see that the values were changing. So if I scroll up, see if I can, if the old values are still there. Yeah, so it started at negative 255, and then the left will become that positive value. Okay, sorry about the scrolling. It is, okay, let's stop the simulation, and then it should allow me to scroll without having to deal with this. Yeah, okay. So the left is started at negative 255, and then it slowly became that like slightly positive number that we decided. And then you can see right after that, the right side also changed to full positive. So it's kind of just receiving all of those commands and live updating them to the motor speeds. So TinkerCAD, unfortunately, is a little bit slow, so you can't get like super fine, like exact what exactly is going to happen. But it's super useful for you to kind of like rough draft what your circuits would do, and then it makes it a lot easier to build it physically, and you can have an idea of whether or not your circuits would work once you get there. So yeah, that's how you can control this little car with another Arduino with I2C. So unfortunately, we didn't really make use of this ultrasonic sensor. But another thing you could do is there's ways to send data back to your leader from the follower. So you could maybe send this ultrasonic reading back to the leader, and then the leader could have like a little display that says like, oh, the car is this many inches away from the wall, you need to slow down. Or you can have some like default code within the car itself that says, if I'm being told to go forward, but the ultrasonic sensor is very low, then just like don't go forward. But yeah, that's just a little bit that you can do with I2C to control another Arduino. So I know controlling a car with a wired controller may seem a little bit silly, just because now we have like wireless car toys and stuff. But you can imagine you could use this for like something more small scale, where like you have one Arduino that's like controlling the motor for like if let's say like you were doing something that controls like the watering of a bunch of different plants, probably isn't the best way to do it, but maybe you had like one Arduino by each plant, and then you could have like one master or leader Arduino that tells each follower when to like open the motor to water its like respective plant. So that's just like one small project you could do using this simple serial communication. So next Friday, it looks like it's just you, Pajit, who was able to stay. Next Friday, we'll still be using TinkerCAD. We will be creating an Arduino infrared speaker controller. So the piezo speaker is just a small little thing that can make a buzzing tone within TinkerCAD, and we have a couple here. We can show you a physical one next week. And then we'll be configuring it to accept inputs from an IR remote. So now you're kind of moving into the wireless control, since we're using a remote, which doesn't necessarily have to be like right next to the Arduino with the speaker on it. And to prep, go ahead and create a TinkerCAD account, but hopefully you already did that for this workshop. Yeah, thank you everyone for coming. We will see you all next week at the same Blue Jeans link at the same time. And fill out this big link for joining the mailing list and join the other social media. Bye everyone.